Sometimes equations that mathematically have less work to do actually feel more difficult to some students because the flow has been interrupted. The pattern, what they always do, gets changed up just a bit. But it doesn't actually change, you just kind of jump in at a different point. Take a look at this equation. I see that I have an x squared and a y squared. They're both positive, but my coefficients are different, which means I have an ellipse. And for an equation like this, you can imagine that you've already completed the square, and the center is just 0, 0. So for a problem like this, all I have to do to finish it out is divide by 4, divide by 4, divide by 4, and now I deal with the coefficients. What I do to the top, I have to do to the bottom. What I do to the top, I have to do to the bottom. And so I end up with x squared, or x plus 0 squared, over 4/16 is 1/4, plus y plus 0 squared over 4/9 equals 1. Dropping parentheses all the way down, we get x over 1/2 squared plus y over 2/3 squared equals 1. You don't have to write the plus 0. If there's nothing there, then that means there's 0 there. And what I have is a center of 0, 0, a horizontal displacement of 1/2, and a vertical displacement of 2/3. So when it comes time to sketch, we're just going to go over 0, 0, then we're going to go over 1/2 horizontally, up 2/3, down 2/3 vertically, and then we're going to sketch an ellipse in there, and big dots fix everything. And no matter how good or bad your drawing is, we're going to label our horizontal displacement and our vertical displacement with their values. Let's look at another very similar problem, but again, one that tends to throw students off. You can see, again, we're dealing with an ellipse. Both of the coefficients on the squared terms are positive, but they are not equal. So we know it's an ellipse. And we can pretend, again, that we're at the point where we've already completed the square. So what do we do with this 1 over here? Well, you just divide by 1, divide by 1, divide by 1. And now again, what we do to the top, we have to do to the bottom. What we do to the top, we have to do to the bottom. And so we have x squared over 1/16 plus y squared over 1/9 equals 1, dropping parentheses all the way down. Gives us a center of 0, 0, a horizontal displacement of 1/4, and a vertical displacement of 1/3. So now again, when we sketch, we just have a center of 0, 0. Horizontally, we go 1/4. Vertically, we go 1/3. And it's a tiny little ellipse right here. I'm going to label my horizontal displacement with 1/4. I'm going to label my vertical displacement with 1/3, and we're good to go. Another version of this so simple it's confusing is 16x squared plus 9y squared equals 0. We know we have an ellipse, but this ellipse is degenerate because it equals 0, and so all we're going to sketch is the center. It's possible for a squared term plus another squared term to equal 0, but that would only happen if each of the squared terms were 0 themselves. So my center is just going to be 0, 0. And again, if we had a problem like this, because it's an ellipse, it cannot equal a negative number. A squared term plus another squared term can't equal a negative. Again, it's considered degenerate, but in this case, there is no graph. Let's look at this equation. 16x squared minus 9y squared equals 4. This time we don't have an ellipse. We have a hyperbola because of the minus sign between the squared terms. So we deal with it just like we would deal with anything else. Divide by 4, divide by 4, divide by 4, and then what we do to the top, we have to do to the bottom. And as we've seen before, we end up with x squared over 1/4. Minus y squared over 4/9 equals 1, dropping the parentheses down. Gives us a hyperbola with a center of 0, 0, a horizontal displacement of 1/2, and a vertical displacement of 2/3. Then the slope of the slant asymptotes is going to be plus or minus rise over run, so that's the vertical displacement over the horizontal displacement. We have a little bit of math to do there. It's plus or minus 2/3 divided by 1/2, invert and multiply, and we end up with plus or minus 4/3. That's the slopes of the slant asymptotes. Finally, we know that this hyperbola will open in the x direction. So now I sketch a center of 0, 0. My slant asymptotes are up 4 over 3, put a point there, down 4 over 3, put a point there, then up 4 over 3, put a point there, down 4 over 3, and again. Because it opens in the x direction, I'm going to grab the horizontal displacement. I'm going to go over 1/2, put a point there, label it as 1/2 up 0, go over 1/2, put a point there, label it negative 1/2, 0, and then go out towards the asymptotes and stay close to them. Out towards the asymptotes and stay close. That creates the branches of our hyperbola. Now let's stick with the same problem here for just a second. If this had been a negative 4, we would have divided by a negative, divided by a negative, divided by a negative. So this negative over a negative would become a positive, and this positive over a negative would kick a negative to the very front of the problem. So now this is our negative term, this is our positive term. Everything else stays the same, except it would open in the y direction. This problem would then have a center of 0, 0. It would have the same slant asymptotes, but we would grab the vertical displacement. We'd go up 2/3, down 2/3. We would label both of those points, and then sketch the branches of the hyperbola in the vertical orientation. If this problem had equaled 0, we would then know that it's a degenerate hyperbola. And in this case, we would only need the center of 0, 0, and then we need the slope of the slant asymptotes. Only we're not dealing with asymptotes anymore. We will be dealing with solid lines. To find those slopes, normally slope is rise over run, which would be y over x. But again, because it's degenerate, we're going to flip it. It's going to be the coefficient of the x term over the coefficient of the y term, and the square root of both. So square root of 16 over the square root of 9. It's going to be plus or minus 4/3, which, as you can see, is the same as the slope of the slant asymptotes that we got before. Except with this particular problem, we can't do the math in the traditional way. The long way would say, let's say each term is over 1, and let's divide out those coefficients. But this shortcut version works nicely and saves us some time. The final sketch for this would be a center of 0, 0, and then solid lines instead of asymptotes. And of course, those hyperbola branches simply wouldn't be there. All right, guys, I hope that makes sense. If you have any questions, let me know. Talk to you later.